Okay, so I would like to do the introduction about the research that a simulation study on the interaction between the line of sight function for motor vehicles and the pedestrian walkability in urban streets. To begin with, this research aims to evaluate the interaction between egress vehicle ex- uh, exiting from off-street and pedestrians walking on sidewalk. Egress vehicle from the off-street need to find a gap between the pedestrians on the and on the to pass through the sidewalk and also should find a gap through between the through vehicles and move onto the main line. And in this process, the vehicle sometimes they stop on the sidewalk or and blocked the pedestrians. And we conduct simulations to represent this kind of situation. And the result shows that the design of the egress vehicle and the percentage of the blockade pedestrians under the different traffic volumes and prohibiting the right turn from the off street to the main street can reduce both the egress vehicle delay and the blockade pedestrians. And waiting the sidewalk is also effectively. It's also effective. This kind of the simulation would be important. While in Japan, the control of the driveway has not been focused on, has not been well considered in street design and operation. And then the first part, the interaction. The driveway provides a direct connection between a street and an abutting property for motor vehicles. This is the first function, the line of sight function for the of the driveway. And if it is not well accommodated in urban streets, it causes vehicle and pedestrian interactions, which will affect the pedestrian's working environment. This is the second function, the workability of the driveway. And the quantitative assessment of each interaction is needed in street design and operation. This study aims to quantify the interaction between the line of sight function and the workability at the driveway except on urban streets by simulations. And then the second part, the simulation algorithm. To begin with, the drivers separate the gap acceptance model into two stages: the process and the throughout vehicle. And based on the gap acceptance model, here is a hypothesis that the egress vehicle accepts any gaps of the pedestrians in the set work or the throughout vehicle on the in the main street that is greater than the respective crucial gap and will reject the gap when it is smaller than the crucial. And then the outline of the simulation. Firstly, the step one is that once the egress vehicle from the off street to the main line. So firstly, when it stay on the line A, so we see this as the step one, and then the egress vehicle wait for the pedestrians on the line A and wait for a pedestrian gap, the first gap. Once the first gap is bigger than the 4 seconds, so it can onto the next step, the step three. So when it is bigger than the 4 seconds, so the egress vehicle can accept this production gap and move to the line B. And then the step four is that the egress vehicle wait for the through vehicles on the main line on off the main line on the line B and wait for a through vehicle gap, the second gap. And for the left turn egress vehicle, when the gap is bigger than 3.2 seconds, it can onto the next step. And once for the if it is right turn egress vehicle when the gap is bigger than the 7, is greater than the 7.1 seconds, and then it can enter and move on to the line road. And then the second, the 50, step 5 is that the egress vehicle accept through vehicle gap, the second gap, and enter to the main road. And finally, it can move on to the main road. So it should be mentioned that from the step 2 to the step 5. So from step 2, when the egress vehicle wait for the second gap, the pedestrian gap, to the step 5 when the egress vehicle accept the second gap, the throughout gap. All through this time, during this time, the pedestrians are blockaded, and after the step 6, when the egress vehicle move on to the main road, that means that the working place space become available on sidewalk for the pedestrians. And then we could analyze the simulation result and the conclusion from two aspects. The first is the impact on the line of sight function of the egress vehicle, and then is the impact on the workability. So firstly, we could see the left figure. We could say that the average delay on line A is affected by all the pedestrians volume, egress volume, the through traffic volume. And this indicates that the line of sight function deteriorate with the pedestrians on the work, just as the reason 1 in green. And it can also be observed that the average delay on line A becomes more sensitive to the pedestrians volume when the egress and the through traffic volume are very high, just as the dark red line shows that. And then let's see the right figure, that the percentage of the blockaded pedestrians. We could say that the workability become worse with the increasing in the egress wheel, just like the two reason as 2. So it changed from the 100 to 200, 100 to 200, and it is also impacted negatively by the through traffic volume, just like the reason 3. So when the through traffic volume become higher, so from the 200 to 300, from 300 to 400, it also have the negative impaction. And then we could see the following figures that one way perhaps the right turn growth as well as widening the sidewalk. So it has the potential to improve both the line of sight function and workability, just as a figure that one way change the right turn allowed to the prohibited, it can effectively affect the average delay and also the blockaded pedestrians, just as the figure shows that. It's all. Thank you for your attention.